In this video, we want to just cover some basic algebra concepts that are going to be important in chemistry. Nothing super difficult, right? There are a lot of topics that are covered in algebra. So this is just basically working with algebraic equations, solving for a variable. We just need to make sure that we remember how to do that, remember some of the important rules whenever we're doing that. And really the rule that's most important when you're doing algebra is that whatever you do to one side of the equation, you have to do that same thing to the other side of the equation, right? So if I ask you, just got a couple of simple examples here. If I ask you to solve for the x variable in each of these, that means when you say solve for a particular variable, it means you want to get that one variable, you want to get that variable and that variable only on one side all by itself, right? So x plus 2 equals 3. If I want to work with this algebraic equation here, I need to get rid of this plus 2 that's connected with the x, which means I need to subtract it out. So I need to subtract the 2 from both sides, right? If I subtract it from one side, I have to subtract it from the other. So x plus 2 minus 2 just becomes x on the left side, and 3 minus 2 becomes 1. So that is the solution for that equation there if we're solving for x, right? Now on this side over here, we want to add 4 to both sides to get this x all by itself. And so again, notice I said both sides. Whatever you do to one side, you have to do to the other side in algebra. And so if you have an equation, if you're adding 4 to one side, add 4 to the other side. So it means that x is going to be equal to 2 plus 4, right? When we add a 4 to both sides, or x equals 6. So we notice here we had x added to a 2, and so we undid the addition by subtraction, right? Here we had a 4 subtracted from the x, and so we undid the subtraction by addition, adding a 4 to both sides. I didn't write it over here on this side this time because we could see that by adding a 4 to this side, we're just going to get rid of that negative 4 there. And so that works because subtraction undoes addition and addition undoes subtraction, right? But here we don't have the x added. We don't have a number added or subtracted from the x. We have a number that's multiplied by it. And so what undoes multiplication? Division does, right? So here we want to divide out this 4 that's next to the x if we're solving for the x. And when we do that, these 4's will cancel out, and we're left with x equals, what is 16 divided by 4? Remember, fractions are just division, so 16 divided by 4 is 4, so that would be the answer for that problem if we solve for x. And then finally, what about this guy here? Well, here we have x that's divided by a 2. And to undo division, we want to use multiplication. So we want to multiply both sides by the number 2, right? Again, whatever you do to one side, you have to do to the other. Now, remember, when you're multiplying a number by a fraction, you can just think of the number that's all by itself as that number over 1. And you want to multiply the top together and multiply the bottom together. So this would be 2x over 2. But for those of you that are that are pretty comfortable working with these, you see immediately that these two will cancel out one another. And so you could just go directly to that final step and say this is x equals 6. Now that's really simple, right? Most of you are going, I know how to do that, no problem. That's about as hard as it gets in here as far as algebra goes. Where people tend to get confused, though, lots of students do really well with this. There is one, there is one particular version of this that students tend to mess up on more than others. Sorry, did not want to do that. I was trying to select this. Let me do that with my mouse here. There we go. It is a simple problem like this. What if you had 12x equals 4? Now, for whatever reason, students, when the variable is on the bottom of the fraction instead of on the top, as we just saw in that last example, students tend to mess this up. It's the same thing, and there's really two. It's the same thing that we did before. We want to get the x all by itself, and right now that 12 is divided by that x, and so that's what confuses students. It's like, what do I multiply this by? They want to multiply the left side by something so that you get x all by itself. But this is really, it's going to take 2 steps in order to get the x by itself. So a couple of ways you can think about it. The first way that you can think about this problem is you could say, well, I want to multiply both sides by x. And if I do that, my x's will cancel out here, and I'm left with 12 equals 4 times x. Now I have a problem that's very similar to one that we've already done. I want the x all by itself, so I'm going to divide both sides by 4. These 4's cancel out, and I get 3 equals x, which I could easily just rewrite as x equals 3, right? So I've solved for x. X equals 3 in this case. If you don't like that version, some of you learned how to do this using cross multiplication. So let's just refresh your memory on that. 12 over x equals 4. With cross multiplication, what you do is you think of both sides as fractions. And so we're going to think of this left side here as being 4, not the left side, the right side, sorry, as 4 over 1. And we're going to cross multiply, which means we're going to multiply these two together, and we're going to multiply these two together here, right? And say they're equal to one another. So x times 4 is going to be 4x. And 12 times 1 is going to be 12, so 4x equals 12. And then we're back where we were just a minute ago, right? We're going to divide both sides by 4 so the 4's will cancel out here, and we're left with x equals 3, all right? Now, again, when the variable's on the bottom of the fraction, students make mistakes, so make sure that you know how to do that. If you don't understand that, look for some additional problems online and make sure that you're prepared to do that type of basic algebra before you come to class, all right? One other thing that tends to confuse students. A lot of students do great if it's numbers with one variable, but if you have a problem that's predominantly variables or even all variables, then they get confused. And so what's an example of that? Well, let me just do a really simple one here. A equals B over C. And the instructions for this, I tell you to solve for C, all right? How would we go about doing that? Well, C is on the bottom of our fraction here, okay? And so we're going to cross multiply just like we did just a minute ago. We're going to think of this as A over 1 equals B over C. And when we cross multiply, this time we'll do, since we want the C to be on the left, we'll multiply this way first, A times C first. So A times C is AC equals 1 times B is B. So AC equals B. Again, we're solving for C, so we're going to divide both sides by A. Our A's cancel out over here, and so C is simply equal to B over A, right? So if I gave you a problem like this and I said solve for C, and then maybe I said, what is C if B is equal to 10 and A is equal to 2, well, you would just plug in those values and you would say that C equals 10 over 2 or C equals 5, right? And that would be the final answer. So you just want to get good at solving these equations for a variable if you've got nothing but variables in there, because many times we will have equations that are just predominantly variables or all variables. And before you start plugging numbers in, it's simpler to just go ahead and solve for that variable from the initial equation and then plug your numbers in afterwards, okay? So that's important that you understand that you could duplicate that work. Let's use an equation that's actually one that we will use in chemistry. PV equals nRT. P and V, P stands for pressure, V stands for volume, T stands for temperature. Those are all things that you're already familiar with. N is going to be something we're going to learn about, number of moles. We're going to learn about that in chemistry. R is just a constant that you just have a number that I'll give you guys for this equation, and you'll just always plug in that number for R. But often when we use this equation here, we need to solve for the number of moles. And again, I told you that the variable N represents the number of moles. So I want you to solve this equation for the variable N. You know, if you're up to the challenge, you could pause the video here and try it on your own and then see if you know how to do it. So I'm going to give you a second to do that. Okay, cool. And now I'm going to show you how to solve it if you didn't know. I'm going to divide both sides by RT because the N is multiplied times RT. So we're going to get rid of that R and that T by dividing both sides by that. And then we're left with PV over RT equals N. But since we're solving for N, I'm going to write the N on the left side and say N is equal to PV over RT. Super simple, right? That wasn't hard at all. That was very, very simple. Here's an equation that we use in chemistry that you have used in algebra. You've seen this before. Degree F equals 9/5 degrees C plus 32, right? So this is how we would convert from degrees Celsius to degrees Fahrenheit. And so let's say I gave you this problem here and I said, I want you to determine if the temperature is 25 degrees Celsius, what would that be in Fahrenheit? And so you would just take it, and most students with this would be like, no problem at all, right? You would plug in 25 for degree C. And some of you would break out your calculators. What I would hope you would do is you would recognize that 5 will go into 25 5 times and realize, oh, I could totally do this in my head. 9 times 5 is 45 plus 32. And then 45 plus 32 is going to be 77 degrees Fahrenheit. So 25 degrees Celsius is equal to 77 degrees Fahrenheit. Okay? So if I gave you this equation here, most of you would have no trouble doing that. But what if we turn this thing around, right? What if I didn't give you the 25 degrees first, but what if I gave you what if I gave you the degrees Celsius first? All right, so let's try that. Let's say we have, what if I gave you the degrees Fahrenheit first and asked you to convert to degrees Celsius? So let's delete all of this. And we want you to find, so I tell you, we'll just do the same number, the solution that we got just a minute ago, and we'll say, I'm sorry, I don't give you the degrees Celsius, I give you the degrees Fahrenheit. So what if I give you a temperature of 77 degrees Fahrenheit? Could you, from that, figure out what the degrees Celsius would be? And you could go ahead and plug in 77 if you wanted to and rearrange this equation. Or you could take this equation right here and you could algebraically rearrange it so that you solve for degree C. So how would we go about doing that? Let's do that. It won't take us but just a second. So we're going to first, we're trying to solve for degree C, so we need to get that all by itself. And we first notice that it is it's multiplied by this 9/5, but we want to deal with that last of all. Whatever it's multiplied by, that's what we'll deal with last. The first thing we want to deal with is any number that's added to it or subtracted from it. So let's get rid of this plus 32 right here by subtracting a 32 from both sides. So when we subtract a 32 from the right side, it just goes away. But on the left side, we're going to have degrees F minus 32 equals 9/5 degrees C. All right. Now, how do you get rid of the 9/5? Well, that's 9/5 times degrees C, and we said we undo multiplication by division. So what we could think of this as is we want to divide both sides by 9/5, right? That would be one way to get rid of the 9/5 here. But when you divide by a fraction, it's helpful to remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So it's actually going to be better for us to think of it that way. We're going to take this 9/5 degrees C and multiply it by 5/9, which is the reciprocal of 9/5. Now again, if I do that to the left side, to the right side, I've got to do it to the left side as well. Okay, and so when I do that, my 9's cancel out, my 5's cancel out. I'm left with degrees C on the right, and I've got my I've got what degree C is equal to on the left. So we're going to flip it around since we were solving for degree C, and we're going to say degree C equals 5/9 times degrees F minus 32. Now we're ready to take this 77 and plug it in. So let's do that. This is equal to 5/9 times 77 minus 32. What is that? Well, 77 minus 32 is 45. So we have 5/9 times 45. Again, hopefully you guys are all seeing that 9 will go into 45 5 times, and 5 times 5 is 25 degrees Celsius. So we got the answer we started with in the last problem, right? But it required some basic algebra to be able to solve for the correct variable and then plug in that number. So again, these are concepts that are going to be critical. By the way, if you just struggle in general with basic algebra, it's not going away, okay? As long as you're continuing to take classes in school, you're going to have to use this. You're going to use it in other science classes. Algebra 1 is not going away. You're going to use it in Algebra 2. You're going to use it in pre-calc if you have to take that. You're going to use it in geometry if you take that. So it's going to stick around, and you're going to keep seeing it pop up. It pops up in places you don't expect it. It pops up in real life, right? It's a skill that if you get it down, it's not that difficult, but you're going to have to invest some time to understand it. So I would highly recommend investing that time now, getting this down, so that it won't continue to plague you throughout the rest of your high school career. Okay, so go ahead and take the time. Again, if you need more practice, go online. Khan Academy is a great place to look up just basic algebra, solving for variables and things like that. And find some examples, watch some tutorials, and make sure you've got this down before the first day of class. All right, I'll see you in class.